Hi everyone, this is Hannah, bringing you this week's webinar from Strucsoft Solutions Great Tech Group. Today's webinar is entitled Increase Your Revit Project's LOIs with Strucsoft for Revit 2025. As some of you may know, MWF is currently rebranding as Strucsoft. Our software is a Revit-based BIM framing solution, which is dedicated to framing your BIM model in wood or light-gauge steel. This is a great tool to enhance your LODs or LOIs. Today, we are mostly focusing on our product in this presentation, but we will also discuss some general LOI information. Please note that what we will talk about here today is merely recommendations and may vary from project to project according to your contract and your BIM execution plan, which we will talk about in a little bit. So you may find slightly different information if you research other resources. Today's presentation is mostly informational, but we will talk a little bit about some technical aspects of the software at the end of the presentation. Let's start with the bullet points over here. First, we will start with an introduction. What is the level of information? And then we will discuss what are the different LOIs in BIM, which stands for level of information, and BIM, which stands for building information modeling. Then we're going to show a Strucsoft level of information chart and how to achieve Strucsoft level of information or level of information for your framing. The level of development or detail, LODs, is a topic that was previously covered. We encourage you to check out our previous webinar that was dedicated to this topic. Please leave in your comments if you have any other topics that you would like us to cover in the future. And please don't hesitate to ask any questions during or after the webinar in the Q&A or comments section. Now, without further ado, let's jump into our presentation. First of all, for the introduction, what is the level of information? The level of information, or LOI for short, describes the information content of a BIM object at a specific time in the project, also referred to as non-geographical information. LOI refers to the properties of an object, for example, material specification, insulation details, fire rating info, or the costs of the building element at different stages of the project. LOIs are directly linked to LODs. In today's presentation, we are specifically going to focus on non-geographical information of the BIM object, which is something we talked about a little bit in our previous presentation, but we focused on the level of development, which is the LOD. Levels of development are tracked in the project through an LOD matrix, an essential component of a BIM execution plan, also known as BEP. In the LOD matrix, project teams define and outline LOD and LOI requirements for specific building elements and systems at various project stages. The above information is courtesy of Autodesk and the AIA. We encourage you to check out their websites for additional information. Now let's talk about the different levels of information in BIM. What are the different LOI levels in BIM? LOIs are directly linked to the 6 levels of development. The American Institute of Architects, the AIA, and the Associated General Contractors of America, the AGC, have established a commonly used LOD and LOI framework that breaks down the building model into specific levels. These are the 6 levels. Let's explore them. This is the LOD 100. This is the LOD 200, LOD 300, 350, 400, and 500. With regards to the LOD 100 level, which is the conceptual design. At this stage, the model represents the basic shape and size of elements without detailed information. It's used to convey the overall design intent. So this is with regards to the geometrical shape of the model. With regards to the LOI at this phase, the name of the project, the project type, area measurements, user requirements, owner's brief, municipal data, and building codes would be part of the required level of information for the project at this stage. Let's take a look at the LOD 200 schematic design. In the schematic design, the model becomes more refined in this stage, incorporating approximate quantities, sizes, shapes, and locations of elements. It helps in analyzing spatial relationships and early design concepts. As you can see, that framing still does not exist in LOD 200 as it did not exist in LOD 100. With regards to the LOIs for the LOD 200 model, here measurements, materials, quantities, coordination, and clashes should be included. With regards to the LOD 300 or the detailed design model, this is where the framing starts to progress or initiates. As you can see here, I have previously mentioned this in the previous webinar. You can show your framing as critical framing, or you can also show it as a simple framing that looks like this. So with regards to the LOD 300 model, the detailed design, in this phase, the model includes geometric information, specific sizes, shapes, and detailed object components. It would be used for producing construction documents and coordinating different disciplines. This is also where clash detection would be a very important part of the process. With regards to LOIs for this phase, this would include costs, bids, contracts, schedules, fire rating, technical analysis, energy analysis, environmental impact assessment. With regards to your LOD 350 model, which is the construction documentation. In this phase, the model includes detailed assemblies and fabrication or construction level information. This will be used to generate construction documents and shop drawings. In this phase, you can see that the framing is more developed than the previous phase. With regards to the LOIs of this phase, this would include costs, bids, contracts, schedules, fire rating, technical analysis, energy analysis, environmental impact assessment. Let's talk about the LOD 400 model, fabrication and assembly model. Here you can see that the model becomes more and more detailed. With regards to the framing, you can see that we have additional details that include assembly, such as adding clips, hold downs and anchors, and additional details in the rest of your model. The LOD 400 model, which is used for fabrication and assembly, would involve the creation of detailed models. So it could be several models that are linked together with specific assemblies and connections suitable for fabrication and assembly purposes. With regards to the LOIs, this would include fabrication production dates, delivery dates, installation assembly schedules, health and safety documents, quality assurance documents as well. With regards to LOD 500, this is the as-built or facility management model. LOD 500 is the model that is built, basically. It would include information about the installed and operational elements of the building, reflecting real-world conditions for maintenance and facility management. The LOI at this phase would be handover details or dates, maintenance details, asset performance info, occupancy data, and end of use. Now let's talk about a Strucsoft's LOI chart. And here we're going to specifically talk about framing. For the LOD 300 detailed design, this is where actually framing starts to happen in your project. You have two options. You can show your framing as a panel that has all of the panel members, or you can do what I have done here. I have only shown the critical framing in my model. The reason for that is that in this phase, a lot of coordination starts to happen, and you might want to just keep the critical framing for coordination purposes. And for the 300 LOD 300 model, we're going to focus today on the LOIs that you can find with regards to Strucsoft's framing. In this phase, the panel already has an ID, a name, and a number. So if I select this member of the panel, and if I scroll down here in the properties, you'll find that when you frame your model, you will have additional details attached to that member here. I'm using a specific size, but this size may not necessarily be detailed in this level of detail. But what I wanted to mention is that you already have a panel name and number. So you can already start to count how many panels you're going to need for your project, which brings us to the quantities of the panels that you might need. You can start to create schedules and shop drawings for critical framing, and you can also have additional details such as fire rating. If I select this member, click on Edit Type, these over here represent the physical characteristics of this member: the return, the BF, the D, and the TF. There is also some details that you would not see in the model, such as the weight. Additional details can be added over here as the LOI progresses. This is still an early stage, but for example, you can see over here that you can add a fire rating, and you can add a cost, and this can show up in your schedule. With regards to LOD 350, or construction documentation, you can see here that with regards to the panels, the panel is starting to show more accurately. There's more members in this panel than there was over here when we were only showing critical framing. Here, with regards to the framing, with regards to the LOIs of the framing, you will have the panel names and panel numbers just like we talked about before, but you can also have the actual numbers of the framing components within the panel itself. There's also more accurate family properties information. This is where you actually specify a specific size, and you can also create schedules and shop drawings for your panels at this phase, and the quantities of the panel elements are also very specific. And if you can see over here, if I just scroll down, you'll notice that there's a panel label. This is S7, and this one here is S1. This one right here stands for E1 and E2. This would be E2. So you can also see that panel members have specific IDs or labels. This is also within the scope of the information within the BIM model. With regards to LOD 400, the framing here has to be very specific and very defined. Not only do we know the specific sizes we want to use, we need to know how they're going to work together. How are the members going to work together? Additional features include adding clips, adding hold downs and anchors. If you have any holes, they should be showing in this model as well. And anything related to information needs to include, for example, the stud and track type parameters, the fastener counts for framing and sheathing, accurate bills of materials, and detailed shop drawings as well. Elements have to be more and more detailed, so if I click here on Edit Type, information can include the manufacturer. Actually, it should include the manufacturer at this stage, at the cost as well. And I will talk to you about shop drawings in a little bit. With regards to the LOD 500 model, with regards to framing, this should be similar to what we saw with LOD 400. The only difference is that this has to reflect the actual or the as-built. Now let's get into the technical portion of the presentation on how to achieve Strucsoft's LOIs for your Revit 2025 project. So we're going to start with an LOI 300 detailed design. In this phase, you would not have a very detailed panel. So let's switch this panel to something much more simple. I'm going to go to the properties of this panel. I'm just going to select a very basic template. You can start with our light gauge template at this point. I'll set it as active, close, and OK. This is a very simple panel. This is a good starting point. But if you like, what you could also do is go to our miscellaneous menu. And over here at the bottom, you'll find under function, you can use framing only. If I hit on OK, this is how we would change this panel into an LOI 300, LOD 300, LOI 300 panel with only the critical framing around the window or doors and all around the panel. Now let's talk about LOI 350. To switch this back to an LOI or LOD 350 construction documentation panel, I'm just going to switch this back here, go to the properties, and switch it back to either exterior or interior. This brings back the rest of the panel members, but I would like to show you another example. Here I'm just using another template that has a little bit more detail. Details included here would be to, for example, we did talk about the properties of the BIMSF properties that get populated over here, and I did show you that we have specific BIMSF description, BIMSF label, and we also have tags at this point. I would like to show you something here in the wall manufacturer table over here, or menu. If you click on drawing operation, you can add a schedule label, which is one of the topics I wanted to talk to you about. When you add a schedule label, I'm just going to click here. This adds or finds and labels identical members and subassemblies within a single panel with the same value. For individual members, the label is stored in the schedule label parameter. So we have two ways to achieve this. There's distribution strategy type A and this would be for the labels in your panel. And here, if you click on B, this actually finds labels and identical members of the parts of your panel, such as plates, rings, bars, and rods. Let's use this one for now. So I'll just hit OK. This adds another parameter. And in your panel, you'll notice that we have a new parameter that just populated, which can be found over here. I'm just going to expand this a little bit, which is called the scheduled label. This was not there before. This gets added and it gets populated. This means that members that have identical properties will be defined as C0 over here in your scheduled label. They will have the same identity, but they still have the BIMSF label, which is the S1, S3, as we can see over here. So it keeps both. This is also part of the information management that is available with our tool. Additional features also can be found here in the output, where you can use our member positioning tool, subassembly positioning, panel positioning tools as well. What this does is that it stamps framing members according to user-defined criteria. This is also another way of adding additional information to your panel. Again, this is non-geometric information, but it's more labeling information or giving your panel a specific ID. This as well, the panel positioning. This one, what it does is that when you run this tool, this will give a specific identity to all identical instances within the project. So this one here is dedicated to members in your panel. This one right here is dedicated to panels in your project. You can also create wall reports, and you can also create shop drawing generation, which we will talk about in a little bit. We invite you to take a look at other webinars that discuss these features in more detail. With regards to LOD 400 or LOI 400, which is fabrication and assembly, we're going to need to switch this template or this panel into a more defined template. I'm just going to go here in my properties and pick another template for this example. This template that I just switched my panel to, you can notice that there's more defined details in this panel, such as the clips and the hold downs and the anchors that we previously talked about. So for an LOD 400 model, cold form metal framing is developed, just like we see here in this example. And it should have sufficient elements that supports fabrication. This also includes the information that we would need. This includes, but not limited to fasteners, clips, and other related hardware. I'd like to talk to you about another tool, which is the fastener count tool. As you may know already, in our software, we don't actually model fasteners and screws. However, we do have a tool that will calculate them for you. I just want to mention that the reason that we don't model screws and nails is because the model would get too heavy. As a solution, and this is one of the best examples about the information aspect of a BIM model, we have this tool here. You can find it in our Properties menu. If you go to the Miscellaneous tab, and if you scroll down, you can find a tool called Fastener Count. If I click here on Edit, you can add screws and nails to your components, and these will be added just as numbers, and they're going to show up in your schedule. So you can create a shop drawing with a schedule that will show the screws and nails in your project. The way you would add them is you would select the description, parameter, or marker, the type of screw or nail you want to add, what is the usage, is it factory installed, how do you want to add them, do you want to add them for each or by fastener spacing. Then you can add a count and the spacing that you want to specify, and then you would add them by the BIMSF description. In this case, for example, let's say I want to add them to all my EVs, which stands for end verticals, and for my studs. You would have these additional rows when you click on add, and this means that this information is now added to your panel, and you can create a schedule that shows this information. Now if I hit OK and OK, nothing will change in the appearance of your panel, which is like what we mentioned before. There is information populated in this model within the elements of this model that we don't see when we look at it. The last thing I want to mention before we create a shop drawing is for LOD or LOI 500. This would be very similar to LOD 400, except that this model element is field verified. It should be a representation of what is exactly happening on the field. Non-graphic information may also be added to model elements. Another important feature to talk about is Strucsoft's shop drawing or automated shop drawing generation, which can be found over here under Wall Manufacturing menu. You would set up your under Wall Drawings Manager, you would set up your settings. You can create multiple settings for your shop drawings. And then you can specify how many sheets you want to create for your multi-layers or for your single layer. These are the views that I have previously pre-created. And over here, this is the shop drawing that I want to create. I'm just going to hit OK, and I'm going to close. Now to create a shop drawing after I have set up all my settings here in the Wall Drawings Manager, what I need to do is select a member of the panel. Remember that you can create multiple shop drawings at the same time for multiple panels. You can select multiple panels, but for example, I'm just going to select this one. And then I'll go here to the tool and simply click on Shop Drawings. And now if I scroll down in my project browser and go to where it says Sheets, I'll find that there is a new panel sheet that has been populated for panel 8. This is the shop drawing that we have just created. This is also another example of the information that is in your BIM model that can be shown as additional information in your shop drawings. I want to highlight the schedule that was just created. The labels here that have been used are also shown on your drawing. I want to highlight that you can also show your hardware, how many anchor bolts you're using, how many hold downs, and how many clips. And you can see that everything is also automatically tagged. The other thing I wanted to show you is that you can create master framing cut lists, master gypsum wallboard schedules, master hardware schedules, and master plywood sheathing schedules for your project. For your Revit project, this can be created as a Revit schedule. This will show you all the information that you need for all the members that of your framing members in your project. For more information on anything we talked about in this webinar or something we didn't talk about in this webinar, you can find our YouTube channel by clicking here on the first button and going to where it says wall video tutorials or truss video tutorials. This will take you to our YouTube channel, where you can find other webinars and tech tips that are more technical and can show you additional features that we didn't show for today. And this concludes our presentation for today. We hope you found it useful, and we'll see you again next time. Thanks, everyone. Have a great day.